Use it to form a new pizza.
Ew.
That's disgusting.
Okay. Shh. So the idea, guys, the idea of the video is to give you the fact that basically a function, it's just like a machine. You're plugging something in and getting an output or a value in return. The values that you're plugging in were called the domain. So it's a set of all possible input values. That's the domain. We always label that as our x values in the ordered pair x, y. We also call it our independent variable. Independent. Okay, because when we plug it in, that value can change. It can be any value that we want it to be. It's independent. With the range we call it our dependent because the range is going to be determined based off of whatever the domain is. So notice that the y value relied on whatever the x was going to be because the x was what was plugged into that function. We performed an operation on the x in order to receive our y value. So the range, those y values, our output, that's our dependent variable. It's relying or depending on whatever your x variable is going to be. Okay? And then the function itself, it's just a relation in which each member of the domain is paired with exactly one member of the range. Exactly one member. So that's really important to know that the domain can never repeat. Let's write that down. The domain can never repeat. But the range can repeat. Just as we showed before when we had the function y equals 6, it didn't matter what value of x we plugged in, we always got y to equal 6. So the range can repeat. But every single one of your domains belongs to exactly one range. But sometimes the range belongs to more than one domain, and that's okay. So here, we've got a function f of x. That's what we read it as. When we see f and then in parentheses the x, we read that as f of x, f of x. And then again, the x represents the domain, any real number in this function. Okay, so for here we have f of x is equal to 15x, meaning that we're going to take our x values and multiply it by 15 to get our range values, which is our f of x value. So here I've got the function f of negative 3, meaning I want to plug negative 3 in for my x, with the function being 2x plus 1. So I'm taking the 2 and multiplying it by that negative 3, because that's what my x value is going to be, and then adding a 1 to it. Well, what's 2 times negative 3?
Negative 6.
Okay. And then we've got negative 6 plus 1, negative 5. So our final answer for here, when x is negative 3, our function's output, or our y value, our range value, is negative 5. So the domain was negative 3, and the range was negative 5. Go ahead, do B, C, and D on your own. Okay, who can raise their hand and tell me what they got for answer B? Heaven? Not -1. Kendall? -2. So when we plug in a 2 for the x, this is going to wind up being 2 minus the 4. And then 2 minus 4 is going to give us -2. Okay, what about for problem C? Morgan? 16. So if we take our 11, we're plugging the 11 in for the x, and it's now 11 plus the 5. Well, 11 plus 5 is 16. Okay, and then what about for problem D? Problem D, what did you guys get? Annie? -14. So we have 3 times the quantity of x, which was a -6, so 3 times -6, plus the 4. 3 times the -6 is going to give us a -18, plus 4, and that's going to give you a -14. All right, let's go on to the next slide. So for here, I'm giving you the different functions, and what I want you to do is you're going to fill in our function table. So again, the domain represents what value?
What's going in?
What the input, which is called the
Input.
x. Okay, the range represents your output, which is your y. And the rule is just what are you doing to your domain in order to achieve your range value. So you have to create a listing of your domain first. So for me, I always make sure that I have at least 1 negative, a 0, and 1 positive. What I want you guys to do, oh, that's a brace. That's a brace. So for your domain, I want you to choose the values -2, -1, 0, and 1. And then we'll plug those in for our domain. So we have a -2, a -1, a 0, and a +1. And then we're going to input it into our rule, meaning our rule is x plus 5. So I'm taking each of these values and I'm going to add 5 to it. So I'm doing -2 plus 5, -1 plus 5, 0 plus 5, 1 plus 5, and then I'm going to get my range value. What's -2 plus 5? 3. What's -1 plus 5? What's 0 plus 5? And 1 plus 5. Okay, so there is our input and our output. I want you guys to do the same thing for these two problems, using the same exact values of domain, -2, -1, 0, 1. All right. For problem B, if I have my domain, I know that my rule is to do what? Subtract 7. So from each of these, we're going to subtract 7. So who can tell me what's my list for my range for problem B? The list of the range. Elijah? Very good. -9, -8, -7, and -6. Okay, so for problem C, my rule is to take my x value and multiply it by 4, and then to subtract the 1. So I'm going to take 4, multiply it by -2, subtract 1. 4 times -1 minus 1. 4 times 0 minus 1. 4 times 1 minus 1. And then I'll get my range values. Who can list off the range values for problem C? Colin? Very good. -9, -5, -1, and +3. Okay, real quickly, because we don't have much time left because you guys are supposed to be leaving right now, I want to go ahead and go over the last part. Tomorrow in class, you guys will do an assignment. So you won't have homework tonight unless you want to get onto the Prodigy and finish up your Prodigy. But let's go ahead and finish this. Let's go ahead and finish this up. So there's approximately 770 peanuts in a jar of peanut butter. The total number of peanuts, P of J, is a function of the number of jars of peanut butter. So to identify your independent and your dependent variables, your independent variables is what the function is about. So what's the function about?
Peanuts.
The jars. It's actually a function about the jars. So it's P of J. It's a function of J. So it's a function of the jars. So that means our independent value is the jars. How many peanuts we'll have is determined off of how many jars we have. How many peanuts we're going to have is going to be determined by the number of jars that we have. So those peanuts depend on the jars. So independent is the jars, dependent is the peanuts. Now, based off of the situation, what kind of values can we have for our domain and range? Like what type of numbers? Can you have negative numbers? No. Can you have fractions or decimal numbers? No. When we're creating our jars? No. No. So they have to be whole numbers. They're going to have to be whole numbers, no negatives, no fractions or decimals. Okay, they have to be positive whole numbers. Okay, now the function itself, P of J, is going to look like what? How will we figure out how many peanuts can come from each jar? What would we have to do to each jar? So there's 770 in each jar, so, So are we going to take a number of jars and divide it by 770? Multiply. You're going to take each jar and multiply it by 770, right? One jar has 770. 2 jars is going to have 1,540, and so on and so forth. Okay? So now, if I wanted to know, hey, what's the value if there's 7 jars, then we're going to take 770 and multiply it by 7, and that means that our P of J, our function of the jars, is going to equate to 5,390 peanuts. It is a whole lot of peanuts. Hope you're not allergic. All right. Get that copy down.